Good afternoon, chat. This is Moise. I'm gonna be going over how a generator turns mechanical energy, like spinning motion, say something like a bike pedal, into electrical energy. It's based on a process called electromagnetic induction. Same idea used in wind turbines, hydro dams, really any kind of like clean alternative energy. Okay, so to start off, we've got two key players to every generator. Generators convert mechanical to electrical, and how they do so is through the usage of this figure right over here. This gray cylinder is called a magnet, and this coil over here, or the spring, is called a, you guessed it, coil. And so what the magnet is typically just a block of metal that's magnetically charged. They can really be shaped any which way, but they all share a common factor in that there's a north pole and a south pole. And this difference in polarity means that there's a magnetic field surrounding it. So these lines I'm drawing around it sort of give a visual demonstration of the magnetic field around the magnet. The magnetic field is practically just an invisible force field around this magnet. The coils, on the other hand, are just electrically conductive material. That means they allow for the flow of electrons. Metal is a good conductor. Ceramics, like pottery, is not so much of a good conductor. And how does mechanical movement generate current? This is where the really cool stuff happens. What happens is you've got a magnet, right? That magnet I drew up there, let's draw it again down here. NS, really bad, but this is north, this is south. So what happens is this magnet, when it gets moved through this coil, like in and then out, so maybe you pull it into here and then you pull it out. What happens is the magnet and the electrically conducting like wire generates an electrical current. The movement of the magnetic field is like a pump, like a piston that pushes the electron river through the wire. So it's like Minecraft terms. We've got a piston, right? A sticky piston. And so here's the piston. This is the magnet itself. And what we've got is say, a block. So this block could be called electrons. And this sticky piston is a magnet. I just did MG for that. And so what happens here is this sticky piston pushes the block in and out of the magnetic coil. And so when that does that, it essentially results in a flow of electricity. Electricity is just a flow of electrons. So if an electron is going that way, that is a current. A current is like water. You remember how I explained that to you about the UDF? Anyway, what it sort of means is that there's a current being generated when this magnet is getting pushed through this coil. So when it goes in, it creates a positive charge. When it comes out, it creates a negative charge. And it can be modeled with this mathematical equation equals to negative derivative of the magnetic force of time. So B is just pretty much an equation for how strong the magnet is. T is just time. So as there's a change in time, a change in magnetic force over time, the change in magnetic force is here. So when you add the magnet, it increases. When you remove the magnet, it decreases. And it can be modeled with this equation. So that pretty much explains how a generator works. And then in the next part of this video, I'll explain how a generator produces